Right. We are doing the which one was it? Sorry, the lesson number. This one, cantilever and further support, wasn't it?
You said it's not difficult anymore.
It's not
Too much.
too difficult.
Liar. Yeah.
Yes, that's right. Okay.
Not believe you.
No, never believe me. Is this it? No.
Yes.
Yes? Are you sure?
Pretty.
Yeah, it's this one.
We have two homeworks or one?
One.
All right. Okay. All right. A girl opens a 4 centimeter lid off a bottle by applying a couple of 1 Newton meter. What was the force? Okay, so the formula here. D equals 0.04 and the couple is 1 Newton meter. So you have dF equals L. So F equals L over D, which is 1 over 0.04. What's that for? 25?
Yes. Yes.
Congratulations, you got the first question right.
Only one.
Let's have a look at the second one. A braced cantilever steel beam is supported by a 26 meter stay. The stay is 10 centimeters above the hinge and the beam is 24. Okay, so it looks like this. This distance here, what did I say it was? 24. And this distance here is 10.
Should I change to meters?
Later you can. Wait, you didn't change it
Yes.
for the whole question?
Yes.
Problem. And this distance here is 0.26. So, this angle here, let me calculate it for you.
The stay is not mean here. The wall.
The stay is the support, right?
The stay is the wire.
The wire is not just rely on the wall.
This is the wire here, from here to here. What did you think it was, Amanda?
0.10 basically.
You thought this was the wire?
It stays. So I translate it like maybe.
No. I said the wire is 10 centimeters above, meaning it starts here. Isn't it? Hang on. The stay is 10 centimeters above the hinge.
Where is the hinge?
There's the hinge. Right. Tan inverse 10 over 24. So we can resolve. Here is T cos, and here is T sine, and here is the reaction as well. But what do I want? I want the tension. Oh yes, of course, and there's the weight. 25G. And then there's a reaction here of ore. And of course there was the tension here, which is T. So this one here is T cos 22.6, T T sine 22.6. What?
Oh my god.
What is wrong?
Terrible. Write down the angle is 22.6 and I multiply with 14.
You what? Oh no. Right, so
Terrible.
let me know when you're ready for me to continue.
Wait,
I don't think they're ready.
I'm
Right.
not happy.
I know you're not happy. Is it okay, Soggy?
Why are that way?
Ah, you missed the last class. And I explained it in the last class. Let me explain again. So, when I push against the wall like this, the oar is this way.
Yeah.
Yeah. But if I lean backwards, I want to fall down. If I lean against the wall is pushing this way, but I don't fall down. So the wall is also giving me a reaction upwards. You know, like I was like leaning. So here, the wall or the nail or the screw is holding the steel here. So there's an up force to stop it falling, and there's a force to the right. So together, it makes this. Yeah. Also, if there was no up force here, if this was the only up force, then it would want to fall down like this. So there must be two up forces. Okay. Right? Yes? Now, where will we take the turning point?
Up.
Oh, no colours.
Hinge.
Hinge. Here.
yeah.
Yes, please. So the first force here, is it clockwise or anti-clockwise? Clockwise. This one? This one?
That one.
Where?
This one?
This one is no.
Nothing.
No.
This one?
No.
Nothing. This one? Anti-clockwise. So you have 0.1225 G must equal 0.24 T sine 22.6. So T must equal.
Where did you get 0.12?
It's half the distance.
Oh, because in the middle.
Yeah. 319 newtons. This tan inverse 0.10 over 0.24.
No 10, sine. I use different.
That's fine. You should get the same angle.
Yeah.
Yes.
So we did this one, 0.12 into 5 degree.
Yeah.
It's anti-clockwise and it's clockwise. So
One anti, one clockwise. Yeah.
okay,
Mhm.
half the distance
Yeah. Mhm.
multiplied by the
Right.
whole point.
Mhm. Sophie, you had a question?
You don't count friction or tension.
No, because the reason is they go through the turning point, so we don't count them. We only count the ones that turn around the turning point.
How about tension?
Now tension. Yes, we broke the tension. We resolved the tension into this one and this one, so we can forget about this piece now. Did you write this down? Did you? I can go to the next question.
Wait, how did you get?
Taking the distance from the turning point. You're taking the distance from the turning point, like point 24 and point 12. What is point 12 for this mass M, which is dumbbells? Force of this mass, 25 kg. Okay, so this is 0.12. Okay.
Is the distance.
2.4 for this. Y component of T sin.
Yes. 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 Next question. Are you listening to me?
Yes.
A braced cantilever supports a 40 centimeter rod of mass 10 kilograms. The strut is 50 centimeter long. So what you have here, this is 0.4, the mass is 10, so there's a 10G here. The strut is 50 centimeters long, so I'll draw it in black. This piece here is 50.5. So what must this piece here be? This length?
0.3.
Must be 0.3. Thank you, Pythagoras. Yeah. Yeah. What is the reaction force provided? The strut is providing. Now this one here.
Wait, the strut is the 0.5 million.
Yes, that's the strut here. So you're all happy with the idea that there is a reaction force here. I'll do it in blue to keep the colours the same. Yeah? Here's a little bit tricky. Which way do I draw the reaction force? Up, left, right, down, angles?
I think it's up.
Like this?
Yeah.
You think so, wouldn't you? But it's not. The or here. Well, I'll call it S. But the reaction force here.
Maybe go down. Right angle?
I think it's at an angle.
Angle?
Yeah.
No.
Yeah. I think it's like at an angle here. I'll call it S here. No, that's wrong. That is completely wrong.
Facing that way.
It should be facing the other way, shouldn't it? Shouldn't it?
Yeah.
Yeah, because this means it should move to the right. But you know what? Actually, I think no. I don't know. I think I drew this one the wrong way. let me think. We need to imagine like this. This is against the wall, and the beam is here, holding it. So, yeah, it's like this is pushing it into the wall. It's not pulling it out. It's like it's pushing it in.
So it's line, the force, maybe direction is just horizontal, not triangle.
Yeah, I don't know.
I think it's like, I think it's northwest.
We need to use our imagination. Uh, no, it's the cable.
You can.
Hang on. Okay. Which way does this want to fall? It wants to fall
Down.
down. So they must be going up. But is this pushing it out
In,
or pulling it in?
can it not push anyway?
I think this one is going left,
That's what I
and this
thought.
one is going right.
Why?
Why would that go right?
This one?
Yeah.
If we zoom in, look here. Here is the beam, and then here is the wood underneath it. Here, yeah. It's like it's trying to push it out. You know. I mean, think about it. If this breaks, this wants to fall down here, and this wants to fall out. This is pulling it back in, and because this wants to fall down, this one goes up. All of these are interesting and difficult questions, and in fact, they really don't matter, because it doesn't matter what way you draw it, because your calculation is still the same. Yeah, I think it's like this.
Going up like this.
There's only one way to find out. Google. Google will answer everything. Here we go.
Yeah, Baidu.
Chinese Google.
Yes.
BAIDU.
I want the right answer, not the wrong answer.
Yahoo. No.
I think the internet.
Blank page.
It doesn't matter. It doesn't matter. I believe it's this. Let's do the calculation.
Why?
You're not happy with it. Here we go. Bing. Right. Braced cantilever reaction. Force. Ready? Go. That's because I spelled cantilever wrong. Right. Reaction force. Or maybe like the diagram. Yeah.
Nothing.
Huh.
What's this?
No, sorry, Google won't help us. Maybe if I type in brace cantilever diagram physics problem. No, sorry, not gonna happen. We'll just think it's like this. In fact, it doesn't matter if we get the picture wrong, because the only thing that will matter is our angle will be wrong. Yeah, like imagine I was supposed to draw, okay, imagine I got I drew it like this, yes, but I got an angle of 200 degrees. So if I got an angle of 200 degrees and I drew it like this, then what does that mean? It's not pointing to the right, it's pointing to the left. So it actually doesn't matter too much, really.
But it matters for the understanding.
I guess if you want that. Anyways, let's see what we can make. So what am I asking you for here? Reaction. The or here. So, you know, it doesn't matter which way you draw this one, because you'll put it at 0. And it doesn't matter here, again, because the horizontal, do we care about this one?
No.
No. And the vertical will still be the same, even if this was going to the left. So, it really doesn't matter. It really doesn't matter. We should still get the same answer. Right,
They
so...
have two reaction force from here to here.
We'll call this theta. Yeah, this is a reaction as well. Now, I suppose it might matter at the end with the angle, but we'll worry about that later. Yeah. Okay, so this one, clockwise or anti-clockwise? This one. Clockwise, and this one? Anti-clockwise. So you have 0.2 tangg equals 0.4 or sine theta. Yeah? So you get or equals
if the force is going for an angle,
yeah.
theta is the outside.
I think this angle is the same as this angle because the beam is pushing this way. It's a bit like with the rope, you know, the rope is pointing this way and the force is also this way. Here, this is pointing this way, so I think the force is also pointing this way. So I think that this angle is the same as this angle.
How do you know?
This angle is the same as this angle. And you can use tan. Ah, yes. So I think theta is tan inverse.
I got it wrong theta. My theta is minus.
Oh yeah, that's very wrong. 53.13. So or equals I got 61.3 newtons.
Wait, how should I get the theta again?
Tan inverse 0.3 over 0.4.
Like, this is same, and this one is same.
This angle here
53.
is the same as this angle, and this one is the same as
This
this
one.
one. Yeah.
Alternating angles.
Yeah. Okay.
No.
Not okay. See, not too difficult.
No.
Very short.
You can't explain why.
No, I can't. That's because I'm bad.
Angle is minus. I'm not happy.
Your theta should be plus. Just think, soon it will be your holiday,
My mom will
and your mother will be here. Yeah.
and asking you, do you know some English more than before?
Yep.
And I say no.
Ah, you can say yes. You
And-
think you now know hash brown?
No, and he take me outside and make point the advertisement. Do you know this one, Minnie? Point to the bus. Do you know where did it go?
You can tell her.
If I don't know, she will say, oh, you have been long time. Why you don't know? Blah 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 blah.
Bring her to the school. We can meet her.
No.
Yes.
No.
Yes. I can meet her. Lorraine can meet her. We can all talk to her.
Oh, I will die.
Yes.
I will translate you wrong way.
Yes. Grace is a bad student. He said Grace is a good student.
No, my mom will. The point, my mom know a little English.
She knows a little English.
Yeah, this is the problem. If she doesn't know or she actually know, it's not the problem.
She knows a little.
Yes, easy word.
Apple, banana,
Yeah,
hash brown.
Better than my dad.
Yes.
You don't know hash brown.
You know hash brown and they don't. All right. Number 4. 13 centimeters, 5 and 15. Okay. Now this one here is a tiny bit different. There's the wall. There's the beam. Here to here is 5. And this is 15.
Should we change to meters and first?
Usually. Now somebody tell me why this is wrong. Somebody tell me why it's wrong. Whoops.
Because the distance.
Why is this wrong? This is wrong. The distance here is 13. Why is this wrong?
The
It's
0.15 is bigger than 0.
Yeah, 0.15 is bigger. So the wire does not reach the end. It only reaches like part of it, you know, like say about here. So if this is 0.13 and this is 0.05, our friend Pythagoras tells us how much this piece is. What is it? 0.12. There is a tension here, and in the middle, how much? 20 G.
Where's 0.12?
Hmm?
No, what is 0.12 at in green?
That's the distance from here to here.
Oh,
Okay, let's get this angle. So this angle here, the theta, is tan inverse 0.05 over 0.12. 22.62 degrees. So this one here, that's t cos. Do we care about that one? No. We care about this one.
what's the point?
This one?
Turning.
We'll take it here. So this one is t sine 22.62. So we have 0.075 20G must equal 0.12 t sine 22.62. So I get T is 319 newtons. Now is that what I'm looking for? No. I want the reaction force here. So I should calculate this one. This one will be T cos. So if I just draw the picture again here, I know this one is 319, and then to the left it will be, sorry, no, bad. Sorry, look, I know this one is 319. So this is T cos and this is T sine. So let me see, 319 cos 22.62. 394 newtons, and then sine 1, 2, 3 newtons. Okay, can I just redraw this picture? Can I go down a bit?
Yeah.
Yeah. So if we look at the beam, that's a beam. How much is this force here? 20G. How much is this force here? Did I say?
TX component.
Yeah, what was it I had? I had 294. And then how much is this force here? 134, was it? No, it was 319. No, sorry. 123. So let's calculate the reaction here. How much must this be?
294.
Must be 294. And this one, let me call it x. You know that x plus 123, what must that equal? 20G. So this must be 73.2 newtons. So I can get my answer. If I use Pythagoras, I can get the reaction here. That's 303 newtons. And the angle, that is tan inverse 73.2 divided by 294. 14 degrees. Tan inverse 73.2 over 294.
So it doesn't matter
Yes?
doesn't matter here is long enough
Not long enough?
to the end.
Oh, it doesn't matter that this doesn't go until the end. Is it okay?
3 or 3
Pythagoras. This one squared plus this one squared.
Sorry, what's the angle?
14. How did I get it?
Yeah.
Ah, that's what he asked me. Tan inverse 73.2 over 294. You know this. You know this. Don't you?
I don't want to use that.
And I'm also hungry too.
I'm not hungry.
You're not hungry because you just had yogurt and sausage and bacon and toast.
No,
Hash brown. This is why you are not hungry. I am hungry because I had breakfast at 7 o'clock. That's a long time ago now.
only bread.
Porridge. No, you know what it is. I showed you the picture last time. Alright. Is this okay? Yeah.
Bye-bye.
No. Now, I was hoping to get 2 lessons done, but I think that might be too much because these were a little difficult.
Which one?
The ones I did. You said they were difficult.
YES.
I understand your English. Let me have a look at what we're going to do next.
English.
How many classes do we have next week? 6, isn't it? 5? No, 6. No, 6.
We had 6 every week.
Yeah, 1, 2, 3, 4, 5, 6. We have 8 lessons left. This lesson here, where is it? This one here is easy peasy. This one here is easy peasy. 1, 2, 3, 4, 5. 5 difficult lessons left. What are you talking about? I think we won't get this section finished until the week after the holiday, which is okay, because your mid-semester test is on this section. So we'll have to have the mid-semester test on like Thursday.
When?
After the holiday. Okay?
No,
Not okay.
not happy.
And neither am I.